chapter, it's not very difficult. You will be able to understand most of the things in this chapter. Gravity, gravitation, a little bit of astrophysics is involved over here. So it's interesting also. And this is not a part of your mechanics. So mechanics entire portion is over. That's a very, very huge branch and important branch of physics. So till rotation chapter, especially Nabila and Aisha, you both have attended each and every class properly. So practice those portions. Those portions are very tough. Gravitation, you'll not find it difficult. It's easy, interesting. And the point which is important that I have already told you, that is, it in class 12th, as it is, similar formula will come. So you'll be able to relate it also. So that's why study properly. Two major things are there in this chapter which you need to focus on: Newton's law of gravitation, Einstein's theory of gravity. Like right now, we will be focusing on this. Apart from it, gravitational, related to gravitational, what all things are there? Gravitational force is there, gravitational energy is present. Okay, so these two things also we'll be studying separately. Gravitation potential, gravitational force, gravitational energy. Three things are there. I'll just tell you so that you know what all things are present in this chapter. So in this chapter, gravitational potential, gravitational energy. In fact, potential energy, they are the same. That is gravitational field, moreover. Okay, and the force. So these things are there. And in class 12th, that is, you will have electrostatic instead of gravitational. Electrostatic potential, electrostatic energy, electrostatic force. So formula is also very similar. The whole concept is a little similar with slight discrepancies. So this is just this is that these all topics are there in this chapter. Otherwise, see, gravitation won't take much classes. Derivations are there in this chapter which you need to focus on. Now coming to the Newton's law of gravitation, what exactly is this law which I was mentioning? Any two bodies are present. Any two. Okay, this is body 1. This is body 2. Let's say this is A, this is B. Any two bodies that are existing. Okay. They have a certain separation. Okay, let's say some separation is there. That is capital R. Okay, so that is small r. Let's take it as small r. Students are joining. Now see, Newton's law of gravitation is there. A body is there, B body is present. R is the separation. So there are basically two major points which you need to remember. First major point that you need to remember is that the gravitational force that will act between two masses. In fact, instead of A and B, also know I'll mention this as M1 and M1, M2. So the first one is, when we talk about this, the first one is that the gravitational force. Gravitational force is directly proportional to directly proportional to the product. Product means, just a second, wait please. Okay. So see, the first point is, yes, all of you, Nabila, Aisha, Sana. The first point is that the gravitational force that exists between these two masses. See, between any two mass in this whole universe, any two mass, be it me, this pen, laptop, myself, anything, means you don't have to take specific two planets to understand this. This doesn't mean that I have drawn two planets. Any two masses, gravitational force will be exerted between them. So the first is gravitational force is directly proportional to the product of masses. Okay, they're directly proportional to the product of the masses. Like if I have M1 and the other mass is M2, it could be anything, a smaller body, a very big body, like Earth is there and you all are present. So like this, any two objects that are present. So the gravitational force that exists, it's directly proportional to M1 multiplied to M2. Okay, product of the masses means multiply the masses. That's it. Second point is that gravitational force is inversely proportional to the square of the separation. Inversely proportional to the square of separation means they are separated by a distance of r. So the gravitational force is inversely proportional to r square, not r, inversely proportional to the square of the separation. Now, if I combine, the gravitational force will be m1 m2 divided by r square. So whenever we remove the proportionality sign, what do we get? A constant, that is capital G, m1 m2 by r square. This is the gravitational force. Okay, the value of this G is, this is known as the universal gravitational constant. And since your first chapter, we have been discussing this capital G. If you remember, in units and dimensions also, I told you that it's a very important concept that is utilized in the units and dimensions questions also, as well as it is independently an important topic. So this topic is very important in terms of this chapter also, but apart from this, in the chapter units and dimensions of capital G are often asked. So using this formula is a very easy, simple formula. Questions are also simple from this. Your vectors should be clear because it's a force. Throughout your work, energy and power, you didn't have any concept of proper full usage of vectors. In rotation also, vectors didn't play a part. So till laws of motion, you had proper vectors because forces were introduced there also. And here in gravitation, your vectors should be strong because it's a force. And force is a vector. So you cannot neglect the part. You cannot add all the forces directly. All the things that we have studied in vectors have to be kept in mind. Besides that, the value of this capital G has to be remembered by each and every one of them. Because this value may not be mentioned in the paper, or even if it is mentioned, it's such a value that is very, very basic and should be remembered. Like few things are there that you should remember, as I tell you, the density of water, the universal gravitational constant. In the second book, Boltzmann constant will come. So there are few things like acceleration due to gravity's value. Do you check up in the question paper whether it's mentioned or not? You remember it by your end only. When to take it as a rounded off value, that's mentioned. But otherwise, you have to remember. So such things you need to remember by yourself. So universal gravitational constant is 6.67 into 10 to the power minus 11. This value is a little confusing with the Avogadro's numbers value. So don't write that value, 6.022, that is different. And power is also different. This is minus 11. Because in class 11, you use Avogadro's number often in chemistry, so it can be a little confusing. Just pay attention. This is 6.67 into 10 to the power minus 11. Now, this is a universal gravitation constant. Just understand few things. You can copy down things because it is completely different. So you should just understand few points first. See, this law is a universal law. When I say universal law, does that mean that it is applicable to every object in the universe? Yes. This is applicable to each and every object in the universe, and it's a force. Force cannot be exerted solely. Single independent bodies cannot exert force. Two objects have to be present for the forces to be exerted. So only two objects with their separation make up your gravitational force, and that's the Newton's law. Newton's law of gravitation is the universal law because this is independent of the medium. This is independent of the medium. Okay, think it in this manner. Let me talk about a little bit of magnetism, though magnetism will come in your class 12th. If you have two magnets, because magnets are some things that we are familiar with and we can experience things with. So two magnets are present. Okay. Now, when you have these two magnets in air, they are attracting each other. Now you dip those magnets in water. The attraction will not be as strong as it was in air. You dip those two magnets in oil and then try to attract them. You will feel, okay, they are not getting attracted as much as it was completely in air normally when you were attracted. Because magnetic force is a material dependent property. The entire magnetic forces that are existing, they change with respect to the medium. It's different in air. You take it in space, magnets will never be able to coincide with each other because of the rest of the environment of the air. So gravitational law, this is a universal law. It is independent of the medium. The same value, if I take, let's say I have two objects with me. Let's say I have these two pens with me. Here, with this separation fixed, their mass is fixed. I have calculated a force. I'll take this anywhere, oil, water, glass, brass, anything. I'll get the same value of the forces here. And not just this thing, when we say the law is independent of the medium, one point is this, yeah, that you take the objects, you calculate their values, it will be fixed in any medium. Another point is that it is actually valid for the universe. Means using this basic formula, no, F is equal to G m1 m2 by r square. I can calculate the force of gravitation between the sun and earth also, between Jupiter. If such a huge planet, if I take Jupiter and the sun, then also I'll be able to calculate. And between the nearer planets also, like Earth and Mars, or Venus, Mercury, like this, these planets also, if I want, I can calculate using the same formula. For these two pens also, this formula is valid. For these two big planets, this formula is valid. So this is the importance of this law, that this is actually universal. So this helps with the fact that you are saved with the medium, because when the medium changes, things are complicated and you have to keep everything in mind. Okay, the medium has changed. So that's why I say this is not a very tough formula. Formula is very simple, G m1 m2 by r square. But yes, value you have to remember. It's 6.67 into 10 to the power minus 11. Okay, so on combining, this is the complete formula. That's all what you should know. And one more thing, see, when the separation, you can see this is inversely proportional to the separation. So if I take two bodies very far away from each other, at a very huge gap from each other, so what will happen? The radius will increase and the force will decrease. By mathematics also and by logic also, if two things are separated, force will be lesser. And by mathematical formula also, this will be the same case, that when the separation is huge, the force between them is less. And if you want to get a very strong force, you have to keep both the objects very close to each other, because when the radius will be less, the force will be very much greater. And this way you can imagine also two objects that are closer will effect a greater force. Now, two more points that you need to remember, that this formula is not applicable for anything in the sense that it is valid only for point objects or spherical bodies. When you use this formula, you have to take in account that you are considering point objects or spherical bodies. Means basically point object means when you're talking about spheres. That's why I said planets. Planets are spherical. So they are taken into account. So you usually have the point masses or the spherical bodies. And it's a conservative force. Now, this I told you in work energy and power itself, and all of you know what is a conservative force. And I think that time only I have told all of you the example also. I think except Sana in your batch, this conservative part wasn't done. but rest of it was completed. So conservative force basically means the work done is independent of the path traveled. It just depends on the initial and final point. So gravitational force is also one of the conservative forces. These are some points that you should know. Please write it properly. And when the law of Newton's law of gravitation is asked, this is what you need to mention. Write it. Then let us practice few numericals based on this. Yeah, one more thing that I have to tell you. See, wait. Look, since this is a force, two things you need to know further also. The SI unit. SI unit will simply be Newtons. Okay. The CGS unit. All these things, though we have discussed previously also, because it's a force, so things don't change. You're dying. If CGS unit is dying, the SI unit is Newton, and it's a vector quantity that you need to keep in mind. This is very important that it's a vector quantity because you will have multiple masses given, so multiple forces will be generated, and finally a concluding force has to be set. So that is from your vectors, nothing new. Revise the vectors if you are forgetting. Okay, please write it till here first. Okay, wait. That was left. Yesterday you couldn't copy the writing part, no? Just write that first, wait. Before starting with this. Equilibrium question was left. This. Okay, this lamina part have you all written?
Yes, ma'am.
Just wait. Could you write the question, Aisha and Nabila?
Yes, ma'am.
Yeah, ma'am.
See, this was the question which we did. I think that is not coming. The portion that I wrote that was not saved yesterday. So, anyways, I'll rewrite this. The total length of this metal bar that was given was 70 centimeters. Okay, half of it was 35 centimeters here, and this given as 10 centimeters. Portion R1P, this part K1P basically, which we can say K1G, this is was utilized, and this was needed, that was 5 centimeters. The other portion also. So I'll just write it. Just wait so that it would be a discussion also, then you can copy. K1G is given as 25 centimeter, which is 0.25 meters. Okay, and the force R1 was given. I told you that when you have two things, you have the translational equilibrium and you have the rotational equilibrium. In the translational equilibrium, I said that upward forces balance the downward force. So upward forces are R1 and this R2. Okay, so R1 plus R2, this will be balancing what? W1 plus W. Now W1 also we calculated in the last class. W1, the suspended mass was given as 6 kg weight. So this was 6 kg weight is written as 6 into 9.8 because 10 wasn't mentioned. No, it said to take this as, so it was 58.8 Newton, while the second weight was 4 kg weight, which is 4 into 9.8, that is 39.2 Newton. Right, 39.2, yes. So when we added R1 plus R2 became 58.8 plus 39.2. That is R1 plus R2 was equal to 98 Newton. That was our first equation which we got. This was 58.8, yes, 9. Now see, rotational equilibrium. In case of rotational equilibrium, what we do, we take the torques. Torque should be equal. Means the clockwise torque should balance the anti-clockwise torque. Now clockwise, we just had one force. This is going clockwise, R1. So R1 into K1G is equal to anti-clockwise. We have two torques. This one, R2 into K2G, R2 into K2G plus this one, the suspended weight one. That is W1 into this. So W1 is 58.8. So W1 into, what is the separation's name? W1G, that is PG, okay, into PG. So when you put in the values, R1 you don't know, this is 0.25 is equal to R2 you don't know into 0.25 plus 58.8 into 0.05. From here, this becomes your second equation, R1 and R2. Okay, now you can write and tell me what's the answer also coming. Question you both have written?
Yes, sir.
Okay. Do the markings and write it. can calculate the values later. Just let me know once done.
Thank you, ma'am. Done, ma'am.
Done.
Yeah, ma'am.
Okay. See, let's practice a question, a very easy question. This is calculate the force between the masses. So one is 5 kg, other is 10 kg. In between the separation is 10. So M1 is 5 kg, M2 is 10 kg, R is given as 10 meter. So force we know it is equal to G M1 M2 by R square. So force will be equal to 6.67 into 10 to the power minus 11. M1 is 5 into 10 divided by 10 square. This you can calculate later. Answer will be around 3 point something. You can calculate later. Just write down this question as a formula based question. The questions aren't so easy like this, but let us just understand gravity. After that, I discuss. Write this first. Done?
Yeah, ma'am.
Okay. And now coming to gravity. So a bit portion of gravity we've already studied in the chapter motion in a straight line when the topic motion under gravity came. So this you all are already aware of, but let's connect it properly what we've already studied. See, gravity is just the gravitational pull of Earth. Okay, that is known as the gravity. You have the gravitational force per unit mass. When I talk about the gravitational force of each and every mass, that is known as the gravity. And gravity we specifically specify for the Earth. Okay, this I'll tell you later also. First, let me just discuss a very small derivations with you, sort of derivation. It's very easy. Let's say this is the Earth present, and you have some object that is present. Okay, let's say this is small m present to a certain height. That is, let's say, L. Now, when we talk about the gravitational force between these two, let's say the separation is h, or in fact, let me take the separation as r only, so that the formula that we relate to will be the same. Now, see, the gravitational force between them will be g. Okay, one more thing. For the mass of the Earth, let me tell you this also. For the mass of the Earth, usually the mass of the Earth is taken as capital M. Sometimes it's written as ME also, or it is written as M also. And radius of the Earth also, the RE or capital R is taken. So here also I'm taking capital M. So capital G, capital M, small m divided by R square. This is the formula. Now, when I talk about the acceleration, the formula is F is equal to mass into acceleration. So acceleration will be the gravitational force divided by mass. So if I put this value, acceleration will be F, this value of F is capital G, capital M, small n by R square divided by this n, and then will be cancelled. Now the acceleration is nothing but the acceleration due to gravity, because you have specifically calculated this. So you get the value of small g as capital G, capital M by R square. Here also the radius, when we talk about radius, is actually the radius of Earth. In fact, the radius that I'll put also, no, I'll put it as that of Earth, because this is looking as if this is to some height. I'll put it like this so that it appears as if this is on the surface of the Earth. Okay. So capital R I'm taking so that this clearly is visible that this is the radius of the Earth. So capital G, capital M by R square. This formula I've told you before also. This is acceleration due to gravity. You put in each and every value, 6.67 into 10 to the power minus 11 into mass. You put it as 6.4 into 10 to the power 24 divided by 6.4 into 10 to the power 6 meter. All these values, when you put, you get the final answer as 9.8 meter per second square. This is the value of acceleration due to gravity. When you round it off, you can take the z's value as 10 meter per second square. Okay, that's the value of acceleration. This is known as the acceleration due to gravity. This g, this is known as the acceleration due to acceleration due to gravity when you put all these values. So mass of Earth, radius of Earth is often used, mass of Earth is used. So these things you should know. This is the value of small g, that is the gravitational pull of the Earth. So G is independent of the mass of the body. Look, mass of the body got cancelled. This is depending on the mass of the Earth, which is constant. Shape of the body and the size of the body, because all the things related to the body that we are taking is independent. The formula is independent. It only has the mass of Earth and the radius of Earth. This is actually E, mass of Earth and radius of Earth. But this formula will also be used. Now, in this chapter, you need to remember this formula as well. From in your first chapter, we used to ignore this. We directly used to take the value, but here you will have to keep it in mind. Okay. Write it. Have you understood till here acceleration due to gravity? All of you.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Write it.
Ma'am, we need to know the mass of the Earth as well.
Yes, mass and the radius both.
Ma'am, is it 6.4 into 10 raised to the power 6 the whole square, or it's already squared?
Where?
The G is equal to
This
in the
one.
denominator.
This is r square.
No, acceleration due to gravity, the one which you wrote with blue, 6.67. When you put the values in the equation.
Okay, yes, I haven't squared it. Yes, corrected. That is the square of it. Correct. Mass of Earth, see. In fact, 6.4 also, no? Just remember it as 6. This will be easier to remember. See, this you have to remember 6 into 10 to the power 24 kg, and radius of the Earth is 6,400 kilometers. This data should be remembered by all. Okay, see, now coming to the superposition principle. So as I discussed with you, when you have multiple masses present, what you do, you calculate the forces between the individual masses. Like, let's say this is M0, this is one mass. And there are multiple masses present, M1, M2, M3, M4 till Mnth. Mn means there are n number of masses. What you do, you calculate the individual forces first. This is the superposition principle that will be used throughout. The class 12 may be used hoga. So you calculate F1, means the force between these two. This will be G M0 M1 by R1 square. Similarly, you calculate the force between these two, then between these two, these two, these two, like this, all the individual forces you calculate. And eventually for the net force, you add them vectorically. Means F1 plus F2 plus F3 plus F4, F5 till Fnth. And all these are added vectorically. When I say these are added vectorically, it means you have to keep vectors in mind. You cannot just add them. Addition in vector means the way we have studied vectors. If it is in polar form, use the parallelogram law and all. This is the law. For a system of n interacting point masses, the net force on the given mass is equal to the vector sum of the individual forces. Okay, this is the superposition principle. Let's see a question based on this first. Because the theory part is just that you just calculate the individual forces and add them vectorical. So it's better we practice it through the numerical. Till the force part, this much have you understood before beginning the question, all of you? Can we practice
Yes.
the Okay. So 3-point masses are present on the equilateral triangle vertices, no? Because AA is there. The centroid means the centralmost part of the triangle, and it says this capital M is put here. This is a capital M that is put. So we have to calculate the force on this. So look, this is A, this is the center O. Let's calculate the force on A and capital M. Yes, Nabila, look in the figure. Tell me what will be the force between these two, capital M and small m, what we have studied. These two. Yes, Nabila. Tell me,
Mm,
what's the gravitational formula?
F equal to GM1
Yes. So what is
M2 by
M1? Anything? Choose one.
MA.
What should, yes? Look at the mass, Nabila. M1 and M2, what should I put from the question? Due to
The
A, I'm
values are
calculating. Yes, Nabila?
values aren't given.
Values means the symbols. What should I put? M1 and M2. What? M1 and M2 are not given in the question. Then?
So A, B.
What is the mass? Look in the question. Between which masses are we calculating?
Capital M and small m.
Capital M and small m. Okay, so in not M1 and M2. M1 and M2 will be replaced with capital M and small m. Got it? Even if the values aren't good. Very good. Divided by
R square.
R squared. Got it? See, very good. This is how it will be directed. Now see, this M and A, these two are the forces, these two are the masses separated by R. That is Fa. Similarly, if we calculate Fb, capital M is there, small m is there. Aisha, what will be the force between?
Ma'am, the same G capital M small m by R
Yes,
square.
correct. G capital M small m by R square. Similarly, when we calculate Fc, this will be G capital M small m by R square. So all the three forces are present, but what have we not written? Their direction. Once the directions are written, then it will be a little clear what we have. E, capital M force on M due to A. What will it do? It will attract it towards itself. Every force, every body will try to attract it towards itself. Like this. This will try to attract it, this will try to, and this will try to, like that. Now there are three forces with the same values. It's like you just have a force F here, a force F here, and a force F here. This everybody should know how to solve. See, these two forces, if we solve, the angle between them is 120 degrees. Let's see. Let's say F dash will be under root. This will be F square plus F square plus 2 F1 into F2 into cos 120 degrees. So 2f square plus 2f square into cos 120 is minus half. This will be under root. 2 will be cancelled. 2f square minus f square will give f square back. That is f. Now look, is it right? 2f square plus 2f square into minus half. 2 will be cancelled, minus half. So 2, yes, this is it. So it means between these two, a force F is acting here. Two forces exactly of the same value, they will give you the resultant answer as E. So the net force will be F minus F, which is 0 in this case, but you can get any other value. So see, that is all about your vectors. Am I clear till this part?
Yes.
Mom, can you explain this question again
Which part, Aisha?
from the beginning?
What have you not understood in this? Tell me, I'll explain you.
After you found FC, the steps you did.
This is clear why these values will be.
Yeah.
Three vectors are there with the same value f, means I have just taken all of these, the FA, FB and FC. These only I have taken it as f because the values were the same. No, that's why. Otherwise, you need not take them same. Now, three vectors in these three different directions are present. Okay, Nabila. So the three vectors in three different directions are present. So two vectors, how do you solve two vectors? Same vectors FF are there with an angle 120. Why 120 degree? This will be 120, this will be 120, this will be 120. Then complete will be 360. So two vectors making an angle, equal vectors making an angle 120 degree will give you the resultant force F back. Now look, Aisha, one force F was left above, this one. These two we have solved and we have got the force downward as F. Two forces exactly of the same value in the opposite direction will cancel each other. So that's why the answer is C. Otherwise, if they were in the same direction, it could have been 2f and then we would have put the value of f from here. So 2 gmm by r square something or anything could have been there. Got it now?
Yeah, Mom, thank you.
All right then. Please copy it from here, everyone.